Ladies and gentlemen, hello and welcome, coming to you not quite live from One Take Studios, where today's topic is graphing and writing inequalities. We are not going to work with anything for solving today, just the graphing and the writing portion of things. Alright, so first up, what are inequalities? Let's examine that word, shall we? Alright, the word inequality. Kind of two parts here. In, and then equal, and then itty. We're going to ignore that part of it for the moment. In this case, is a prefix. That means not, and equal means equal. That's our root word. So if we are talking about inequalities, we are talking about things that are not equal. What does that mean? All right, if I have things that are not equal, well, that means that somebody's got more and somebody's got less. If we think about that in terms of numbers, what might that look like? And you've probably seen these before, all right? So first one I've got is greater than. What does this mean? This is an inequality because we're saying it's not the same as one thing is greater than another, and there goes my focus, thank you very much. All right, so if one thing is greater than another, what does that symbol look like? Well, the first thing, whatever comes before this, is greater than whatever comes after that. So the first one is greater, the second one is smaller. Our symbol looks something like this. All right. Give me an example of two numbers. What is greater than what? Well, how about if I go with this? 5. 5 is greater than 3. If I just say that statement, that makes sense. I know that 5 is bigger than 3, so 5 is greater than 3. But this symbol in the middle gets some people really twisted up, and they're not sure which way to go with that. All right, so a couple of things. Some people draw teeth inside of it, pretend it's a little mouth. It's like, rawr, it's going to eat the larger number. You can do that. That's great. Other things that you can think about, if you look, this has two sides to it. On the left side, it is big, and on the right side is small. Where's the big side? Next to the big number. Where's the small pointy side? Next to the small number. That might help. If you happen to like music and you can read music, this kind of looks like the decrescendo sign, where you start loud and get softer. Big volume, big, small, greater than. All right, so a couple ways that you can think about that. Pick one that works well for your brain and go with it. We also, of course, then have less than. Well, that's going to be the flip, the reverse of that. Turn our sign around. There we go. Less than. Again, the tiny side is on the left, the big side is on the right. Or again, if you want to think about it, the mouth raw, eating the larger number. I can flip these two numbers around. I can put my 3 here and my 5 here. If I read that, 3 is less than 5, that makes total sense. So 3 is smaller than 5. And again, music-wise, this is kind of like a crescendo where it starts soft and gets louder. It starts with something small, gets big. All right, so this is the same idea, greater than, less than. These are our two primary inequalities, but of course, we can do mix and match as well. Because what if I have something that's greater than or equal to? This counts as an inequality even though part of it is equal, because part of it is not equal. So then greater than or equal to would mean greater than, so that looks like the top one on top, greater than, or equal to. Keyword there is probably or. It can be either one of those things. So I can put something like this, where I've got 5 is greater than or equal to 3, and that's a true statement, because 5 is greater than 3. But I could also put 5 is greater than or equal to 5. And that would also be a true statement because of the or. 5 is not greater than 5. Can't say that. But the or equal to. 5 is equal to 5. So that is also a true statement. I couldn't do that up here, but I can do it here. Which means, again, then something similar for our less than or equal to. Less than or equal to, we are talking 3. Less than or equal to 5. True statement. Again, less than, we can see the inequality part, or equal, we've got part of an equal sign to show that it could be equal. And then, again, it's less than or equal to, so it can go either way. So I can say that 3 is less than or equal to 3, because while 3 is not less than 3, 3 is equal to 3. And those would both be true statements. All right, so that's just the general setup here for us. Let's look at some examples going two different directions here. All right, so for starters, we're going to go with, I'm going to slide this guy over here. We are going to go with examples that take something that's already an inequality and turns it into a graph, which means we're not going to work with just numbers. We're going to have some variables in here as well. Now, graphs in this case are not maybe as complicated as some of the graphs that you've seen. We don't have an x and a y here. We're just going to have one variable. For example, x is greater than 2. X is greater than 2. All right, so we're just talking about x's. Think about that. If x is a variable and can be any number, what numbers are bigger than 2? Can I use 2? Is 2 bigger than 2? Nope. How about 3? Is 3 bigger than 2? Yes. 4, 5, 6. All right, so all of these numbers can't be 2, but they can be larger than 2. But now I want you to think. What about 2.1? Isn't 2.1 also larger than 2? So when I go to create my graph is just a number line, one variable, one line, x, one variable, one line. I want to say that, oh, here's 2, and I want to say bigger than 2, greater than 2. Okay, all right, so let's think for a second here. If I start at 3, is that good enough? Not really, because 2.5 is also bigger than 2. So what I want to do looks something more like this. I want to say this is where I want to start, but notice I have an open circle right here. What I'm saying is that this is my boundary. It's kind of like a chain link fence almost. I don't want to include 2, but I want to start there, and then everything bigger than 2 is part of my graph. Now there's different ways that people do this. You can use highlighters. Some people float their whole thing above the line instead of on the number line. Whatever you like, as long as you can read it okay. I like this because it's really obvious to see this is my starting point, and then I do my squiggle because that way I can really see which direction I'm going. All right, so a couple of variations there that you could work with. All right, let's go with, next up, x is less than or equal to 1. All right, so a couple of differences here, things that we know. X is less than or equal to, just like this last one here. So these are going to be smaller than -1, smaller than -1, which if we think number lines greater than, bigger numbers, greater numbers are to the right. If this is less than, my smaller numbers are to the left. But this says or equal to. What will this do for our graph? All right, so I've got -1 this time, and I actually think that it could be -1 because x is less than or equal to -1. So what's going to be my difference here? Watch. What's the difference between that guy and that guy? If it's or equal to, I'm saying not only do I want to start here, but I actually want to use this point as part of my answer. Here, open circle, just a boundary. Here, closed circle means or equal to. So graphs with greater than or less than, open circle. Greater than or equal to, less than or equal to, closed circle. And less than are the numbers that are smaller than -1, so there's my graph right there. All right. Pay attention to the details here. I know that can be difficult to focus on sometimes, but that is truly key. All right. I'm going to do something really quick here. Don't peek, okay? Ha-ha. I just had an epiphany of something that I wanted to change. So let's see. That was going to be like this and this. Oh, shoot, you were peeking, weren't you? You were peeking. All right, fine, be that way. Okay, I turned this around. Why did I turn this around? Because some people get it programmed in their brain. Well, look, the arrow goes to the right. I'm going to shade to the right. The arrow goes to the left. I'm going to shade to the left. But what if it looks like this instead? I switched them. I put the number here and I put the x here. Ooh, whatever shall happen. Well, things to take note of. First of all, thinking. It is greater than, it is not equal to. Not equal to. So I'm going to set up a boundary for this, and my boundary is at -3.5. What the heck is up with that? -3.5. Well, we can do this. Here's -1, -2, here's -3. Where is -3.5? I know that I'm going to be in the halfway, in the middle point, on one side of 3. Some people are not sure. Well, do I go half this way? Do I go half this way? Think about this, 3.5. I'm going negative, -1, -2, -3, and a -1/2 as well. So I'm going to go right here, saying that I'm in the middle between -3 and -4. That's between 3 and 4. That's between -3 and -4. Now, this does say greater than, but look at where the x is. It's on the tiny side of the arrow. This is the big number. This is the small number. I need things that are smaller than -3.5. That again happens to be this direction, to the left, smaller than. So even though the arrow is pointing to the right, Notice where my x is. My x is on the tiny end. The 3.5 is on the big end. Anything smaller, tinier than 3.5. Open circle, open circle. Pay attention to the details. All right, one more of these. You probably already saw it because I caught you peeking earlier. I know you were. All right. We also now have x's greater than or equal to 1 1/3. Ew, 1 1/3. It's fractions. Nobody likes fractions. Of course they do. I like fractions. All right, so here's the thing. 3.5, okay, fine. That's going to be in the middle of something. Where is 1/3? 1 1/3. Here is my recommendation. Notice how when I made this number line, I really spaced out my numbers. By the way, notice that all of my number lines are lines with numbers on them. The spacing should be the same. You're counting. You don't have to count by ones. You can count by 2s or 3s or 4s if you want, but you do have to count something consistently. You don't get to go 1, 2, 3, 4, 7. Nope, does not work. So 1 1/3. Here's 1, here's 2. This is more than 1. What I'm going to do is I'm going to divide the space between 1 and 2. I'm going to divide that into 3 sections. Now I just made 2 lines, but there really are 3 sections there. That's a section, and that's a section, and that's a section. So there's 1 piece, 2 piece, 3 pieces between 1 and 2. Why did I divide it into 3 pieces? Because that's 1/3. So I'm taking 1 of my 3 pieces. So here's 0, here's 1, and 1/3, and 1/3. There we go. 1 of my 3 pieces. So 1 1/3. Now, I made that open circle. Did you catch that? That shouldn't be open circle, should it? No. This is or equal to. This should be a lovely closed circle that we have here. Closed circle. Maybe I make my little hash mark a little taller so I can see it. All right. So, greater than or equal to. There's the or equal to part because I colored it in. It's a closed circle. And greater than, everything that's bigger than 1 1/3 is to the right. Yay, happy day. There we go. Okay? All right. Now, one more type of problem. Here we go. I'm going to ditch that this direction, and here we go. Ladies and gents, this time we're going to do examples, but going the other direction. We're going to start with the graph, and based on the graph, we're going to try to write the inequality that goes with it. So first off, you can see that I've got, a closed circle at 0 and going to the right. What might I write as an inequality? Well, I'm looking for all of the numbers, the x's that are, let's say that's going to be bigger, so greater than, closed circle, or equal to, what number? 0. So x's that are greater than or equal to 0. That would be a way to write this as an inequality. If you feel like doing things in reverse, you could. What if you put the 0 first and then the x? Well, again, I'm looking for the x's that are bigger than the zeros. So I want the bigger part of my inequality sign to be next to the x and the smaller part to be here. This is the same thing as this. All right, so these are both phrases that say the exact same thing, and both of them would be correct ways to write that inequality. Again, it's or equal to because of the closed dot. Watch the details. All right, so we got this guy next. Again, details. This was closed, this one is open, and it's starting at -2, and it's going to the left, going for the numbers that are smaller. So I might write x's that are smaller, less than. Do I want to write or equal to? No, this is just my boundary. This is my starting point. I'm starting at -2, but I'm not including -2. So x is less than -2 is a good way to say that. Could I flip that around? Absolutely. I could say that -2 is bigger than x, because if you look, here's my x's, and -2 is bigger. So one or the other. Do you need to write both of these? No, you do not. I'm just kind of putting them both down so that your brain can process whatever it likes. All right, and last one for today, last one I promise. It's a fraction one because these are the ones that kind of struggle, all right? So take a second, think. What would you write? What are you going to write? Did you just come up with something? It's bigger. It's an open circle. So x's that are bigger than, greater than, not equal to, because that's just a boundary. It's not a point, it's a boundary. What is that? It's between 1 and 2, so it's going to be 1 and something. All right, well, look at the spaces here. I'm going to count over here because it's less complicated. This is space 1, space 2, space 3, space 4. There are 4 sections. Same thing here. 1, 2, 3, 4 spaces, 4 sections. And so when I'm counting this, I'm counting in fourths because it was divided into 4 pieces. So I start here. This is going to be 1/4, 2/4, 3/4, 3/4. There we go, 1 3/4. And x's that are greater than that, and of course one more. If I would like to write it the other direction, I can. 1 3/4 would then be less than my x's because my x's are bigger than 1 3/4. All right, so details, details, details. It's difficult to do these if you're distracted, so do your best to focus. Try to make meaning out of the signs, because if you just memorize them, they're going to keep flipping around in your brain and your brain's going to struggle. All right, practice, have fun.